are joining the Unit 1.2 Waves Sound Unit Overview and Webinar today. My name is Janita Vasquez, and I am the Elementary Curriculum Manager for OpenSciEd. And joining me today is Christy Morrison-Thomas, who was the lead in writing this unit. Okay, so what's happening today? We are going to spend a little bit of time talking about OpenSciEd Elementary in case you're not familiar with OpenSciEd. Christy is going to walk us through the very first lesson, the anchoring lesson in this unit, so that you get a feel for what that looks like in the classroom. Then she's going to take us on a tour of the unit storyline, which means we'll get a chance to dig deeper into each lesson in this unit. And then she's going to talk to us about key features of this unit or things that she is really excited to share with us. So if you're not familiar with our materials, OpenSciEd is an innovative nonprofit organization that brings together wonderful, wonderful human beings to help us develop free, high-quality instructional materials and the professional learning that goes along with those materials. Our units were field tested by over 450 teachers in 9 states. That means that about 10,000 students and their teachers provided feedback on these units so that we can make them the very best they can be. So a little bit about our OpenSciEd elementary school materials. This is our instructional model. And you can see that like middle school and high school, our model starts with an anchoring phenomenon lesson where students are introduced to a problem about the world around them. And then through investigations, students learn, do research, and figure out things about this phenomenon. And then we have lessons in which they put those pieces together, really gather all of their learning and make sense of it together. And the units are built on this storyline model, and it really focuses on engaging students and asking questions about phenomena and using those questions to drive instruction. Lessons within the unit are connected in service of making sense of this puzzling phenomena and in providing coherence from the student's perspective. Our units are designed for flexible classrooms, for real classrooms, and while we have a recommended sequence, the units are built to be flexible and modular so that you can fit them into your school year in the best way that works for you and your students, whether it has to do because of the weather in your region or whether you want to align the science with your mathematics or social studies learning. As you can see, for all of our grades, we offer 4 units for the full school year, and K2 specifically. Each unit is made up of 10 lessons, but in OpenSciEd, we do not mean a lesson is one day. A lesson can spread out over the course of days in a school day, in a school week, or across weeks. Each of those lessons is 60 minutes, and again, can be scheduled flexibly where it fits in your schedule, for a total of 2,400 minutes per school year, which adds up to less than 2.5% of your instructional time. Okay, so we think it's really important to integrate mathematics into our science learning. Any math that our students see is in the service of strengthening that math learning. We are never doing math just to do math. It is always aligned with what we're learning in the unit. And we do this by integrating a lot of math talk, math modeling, and more than anything else, we think about developing students' data concepts. We talk about data, collect data, analyze data all the time in our units. Also with literacy, we think it's really important, especially in elementary school, to implement and integrate literacy into all of our units. So you will see that we have designed a collection of students' book created by our own writers. Always informational text. That is all the text that we bring in our units is informational, and we leverage those tools to gather information, to use new vocabulary, and to engage students in different ways of communicating their ideas, which can be either orally, in writing, drawing pictures, using gestures, using students' home language when that is in English, if that's what's needed. We think it's really important to focus on communication. Okay, we also offer a comprehensive assessment system. So as you can see, we have different kinds of assessment opportunities for our students. More than that, we offer rubrics. We offer guidance for you as a classroom teacher to, yes, you're gathering this data, but then what happens? What do we do after we have these assessments? What happens in instruction? We guide you through what you will need to do in the classroom once you gather student data through assessments. Okay, and for those of you that are interested, while you can get all of our materials on our website at no cost because we are an open educational resource, we do also have partners that help us to provide kits of manipulative materials for those investigations in classroom, and also vendors that help us to provide printed copies of our materials if you need teacher guides or student handouts. You can find more information for that on our website. All right, so now I am going to hand this over to Christy so she can talk to us about Unit 1.2, Waves and Sound.
Thank you, Janita. Hi, everybody. I'm Christy Morrison Thomas. I've worked on the 1.2 public release unit, and I just want to say thank you for joining us and listening. It's my great joy to help you get to know Unit 1.2 Waves Sound. The 1.2 unit's overarching question is, how can we communicate using objects that make sound? Like other K-2 units, it is comprised of 10 sequential lessons, most of which are 60 minutes long. In this particular unit, the very first lesson is a bit longer. It is planned for 70 minutes. As we introduce you to this unit, we'll highlight each part of the Open SciEd instructional model. We'll start the introduction to Unit 1.2 by spending longer talking through the anchoring phenomenon lesson. In all units, this first lesson introduces an interesting phenomenon or problem, provides an opportunity for students to share initial ideas and experiences, motivates students to ask questions, to investigate and answer throughout the unit, and provides a pre-assessment opportunity for teachers. So our unit begins by the teacher telling a story about when they or someone else heard a sound that shared information without using words. The teacher might say something like, "Recently, I was outside at a park near my sister's house, reading my book, when I heard a sound that got my attention. It sounded something like this."
Christy, the sound didn't play.
I wonder if that's a share setting, Janita. Do you want me to stop and try or just keep going and we'll put it in later?
Let's stop and try.
Okay. That did not cross my. Do you hear
No,
it?
nope, I don't.
Huh. Wha- Our unit begins with the teacher telling a story about when they or someone else heard a sound that shared information without using words. The teacher might say something like, "Recently, I was outside at a park near my sister's house, reading a book, when I heard a sound that got my attention. It sounded something like this." After listening to the sound as a class, we ask students to share their ideas and experiences. For example, we ask, "What do you think the sound is? When have you noticed a sound like this before? What was the same? What was different? What did the sound from your experiences mean to you?" Then, we reveal to students that the mystery sound is the sound of bells inside a clock tower. We invite students to share their initial ideas about what they think the clock tower sound means and what they think people might use the clock tower to communicate. Then, we invite students' ideas about how we could find out more about sounds that people use to communicate or share information so that we can figure out what is being communicated through the clock tower's sound. This navigates us into reading a book next. Let me pause just for a moment to point out the student activity icon showing a whole class activity on this slide. You will also notice icons for individual and small group work in this lesson. Other lessons also organize student work into pairs. In this interactive read aloud of the What's That Sound book, we listen to sounds and view images. For each one, we guess, "What's that sound?" And then we read to find out what the sound is and why people use that sound. With each sound, including a whistle tweeting, a doorbell buzzing, and a crosswalk beeping, we invite students to share their experiences, making connections to their inside and outside of school lives. Then, at the end of the book, we hear another clock tower, dong, ing, and we find out that people use this sound to communicate the time. Like all of the sounds in this book, it is a signal that sends information without using words. We begin an Our Examples chart to gather examples of different objects that make sound signals for us to add to and refer to throughout the unit. We start by adding examples from the book, like the clock tower, a car horn, and a whistle. Then we encourage students to be on the lookout for sound signals in our communities through this out of school sound signals community connection. This way, we can add these to our examples chart as we figure out ways people use sound signals to communicate. Spending the first part of the lesson so far connecting to our various experiences with sound signals is important for building relevance and interest among students and in helping them see science as relevant to their lives and communities. Now, we transition into an opportunity to gather initial observations and ask initial questions about our shared experiences with the anchor phenomenon, which is the clock tower making and sending a sound signal, bong, bong, that people use to communicate the time. As is common in grade 1 units, we gather in a scientist circle so that we can listen and respond to everyone's ideas. First, we re-watch and listen to the clock tower sound signal, making observations or noticing details using our senses by playing the video and noticing the images of the bells inside the clock tower. Then, our teacher introduces our notice and wonder chart as a place to record our observations and questions. This is important in science so we can keep track of our thinking and identify what we can figure out next. As we add to our notice and wonder chart, we can use sentence starters like I observed and I wonder to help us share our ideas. During this discussion, students generate noticings and wonders about the clock tower and bells. Students may notice there's more than one bell, and they may wonder why the bong sound stopped and started. They may also generate questions about who hears these sound signals, how people hear sounds, and how the sounds get to people. Together, we use our observations and questions to co-construct a lesson set question, like how do objects make and send sound signals? This question will guide our work for the first part of the unit. If your class schedule provides about 30 minutes for science time, you would likely pause this lesson here and pick up with the next Explore component on your next science day. Especially if you're continuing science on a new day, we pause to recall that we're trying to figure out more about how the clock tower bells make and send sound signals. So next, we use the images of the bells in the clock tower, here on the slide, to compare to handbells that we have in the classroom. We notice they are similarly shaped and they have a wiggly part that hangs down in the middle. It's technically called a clapper, but students can use descriptors that make sense to them. In the teacher guide, students call it a dinger. We realize we can't explore the actual bells in the clock tower right now, but we can explore the handbells in our own classroom. So we decide to use the handbells to make observations and ask additional questions that can guide our science work. As students explore the handbells by touching, moving, looking at, and listening to them, they each record their observations and their initial ideas through drawings and words on this bell sound observations and ideas handout. This exploration time also provides an opportunity for the teacher to facilitate discussions with students, asking questions like, did the handbell make a sound? How do you think that happened? You'll notice the check mark on this slide. That icon indicates an assessment opportunity. In Lesson 1, this is a pre-assessment opportunity to gather evidence about students' initial ideas about the lesson level learning goal, which is aligned with the unit's physical science performance expectations. Following our exploration with the handbells, we return to our notice and wonder chart to add additional observations and questions. We share new observations, like how the handbell went ding, ding, and that we saw this dinger inside the bell move. We also ask some new questions related to these observations and to our initial ideas about how the bell might make sound. For example, we wonder whether or not all bells work the same, and we wonder if the handbell can make a sound even if we don't move it. Then, after adding these ideas and questions to our class notice and wonder chart, we decide to generate a class model to capture our initial or starting ideas about how objects make and send sound signals. We focus on our anchor phenomenon, working on an initial model for how the clock tower makes and sends a sound signal. We again refer to our bell observation and ideas handout as we share our initial ideas. Students also actively contribute to how we should represent our ideas in drawing and writing on this class model. This input is an important part of the practice of developing models because it builds our experiences representing parts and relationships in ways that can help us clarify our ideas and identify areas of uncertainty. Discussion prompts support the teacher and the class in co-constructing this initial model. For example, we discuss and decide to include the objects making sound, the clock tower and the bells, as well as the sound signal, the bong, bong sounds we heard. In the sample model, we use zigzag lines and the word bong to represent the sound. We also capture our initial ideas about how the clock tower might make and send the sound signal, but we're not sure about those, so we use question marks in different colors. For example, we think maybe the bells are moving, or maybe there are parts banging into each other. We're not really sure yet. And we're also not really sure yet about how people hear the sound signal and if they have to be close by or if they can be far away. At the end of this first lesson, we transition back to our notice and wonder chart to add additional questions or wonders that we generate as we co-constructed our initial model. Then we share ideas about what we could explore next to gather more information about how objects make sound, and we generate suggestions for using different kinds of instruments. These ideas and questions lead us into our next lesson. So to summarize lesson 1, the anchoring phenomenon lesson, we observe a sound, the clock tower, share related experiences to connect to ours and others' experiences with sound and sound signals. We read a book to find out about using sound signals to communicate. We notice and wonder about a clock tower and its bells. We play and explore with handbells and add to our notice and wonder chart. And then we create a class model to record initial ideas about how the clock tower makes and sends sound signals. We figure out that people can communicate or share information by using sound signals. And we figure out that we have a lot of initial observations, ideas, and questions about how the clock tower makes and sends sound signals and how objects like bells make sounds. As we prepare to move on in our Getting to Know Unit 1.2 webinar, we want to note that an integral part of our storyline instructional model is navigation. Deciding together between steps what we need to do next so the unit is coherent from a student's perspective. This way, the class has a shared mission to figure things out, and the sequence of work in the unit helps them make progress on answering their questions. If someone were to ask a student, "What are you doing today?" they should be able to connect back to their own questions about this phenomenon. We're trying to figure out how this clock tower makes and sends its sound signal, rather than just, "My teacher said this is what we're doing today." So let's tour the rest of this unit by lesson type and see how the lessons are connected. Most of the lessons in a storyline unit are investigation lessons. Through investigation lessons, students engage in science and engineering practices, collaborate to create a plan of action, and the teacher provides students with space to grapple with, figure out, and make sense of science ideas. The instructional model graphic here loosely follows a 5th grade unit where investigations involve measuring plant growth, investigating insects, and reading with partners and as a whole class. Let's see how investigation lessons play out in Unit 1.2. In Lesson 2, we first play and explore with triangles, following our ideas from Lesson 1 related to using different instruments to make sounds. But when we try to compare our observations after this initial exploration, we find that what we did and what we noticed were different. So this provides us with quite a bit of uncertainty. We realize we actually need to make a plan for how we will investigate our question about how triangles make sound. So we read a book to find out how scientists make, record, and use observations to answer questions. Then we plan and carry out an investigation by hitting the triangle with its striker and making and recording observations of what we hear, see, and feel when the triangle is making sound and when it is not making sound. The triangle investigation plan that we co-construct becomes a scaffold that helps us make decisions about using materials and making and recording observations in future lessons. Our observations during our investigation provide evidence that the triangle makes sound when it is moving or shaking, and it does not make sound when it is not moving. but we are still wondering about how other objects make sound. Are other objects like the triangle? Do they also move or shake when they make sound? So in the lesson 3 investigation, we want to figure out if other objects also make sound when they move, like the triangle. We plan an investigation to observe different instruments making sounds. We use a box guitar, a shaker with beads in it, and a tambourine that we hit. Like in lesson 2, we make a plan for how we are going to use the instruments to make sound and for how we are going to make observations using our senses and how we're going to record these. We investigate using our instruments and observe that when the instruments are making sound, we see and often feel movement. For example, we see the rubber band on the box guitar wiggle back and forth, and we can feel it tingle our fingers. We use a class data table that we make sense of in order to make sense of our observations. Analyzing our class data allows us to identify a cause and effect pattern that moving or shaking instruments make or cause sounds. We wonder about the triangle and the handbell from our previous investigations, so we return to those and determine that this cause and effect relationship also applies to them. Finally, we read a book called Make Some Noise to connect our experiences with instruments to examples of other objects and materials making sound. We find out vibrations are the small, fast movements back and forth that we have observed. At the end of lesson 3, we return to our notice and wonder chart to identify questions we have now answered, all about how objects make sound, and identify questions we still have, many of which are about what happens after sounds are made and how sounds are sent. So these questions about what happens after sounds are made and how they are sent navigate us into our next investigation lesson, lesson 4. In this lesson, we reconnect to the clock tower phenomenon from lesson 1 and our own experiences noticing sounds made far away to co-construct a lesson question like, how can we know sounds travel and are received? We lean on our experiences planning and carrying out investigations so far to decide we can use an instrument, in this case a drum, to make sound. To answer our lesson question, we want to figure out the different ways we can gather evidence that sounds travel and are received. Our teacher shows us a prepared tube with plastic wrap covering one end, and we notice how it is shaped kind of like our ears. C or O-shaped. So we decide we can make observations using this tube by holding it, using our sense of touch, and watching it, using our sense of sight. But the plastic wrap is clear, so we realize it's hard to see. We decide we can pour a little bit of colored sprinkles into the tube to cover the clear plastic, and this makes us call it our sprinkles investigation. It's very exciting. We work with a partner to carry out our investigation, and we record our observations in a data table that we co-design. We observe the sprinkles bounce and the tube wiggles when the drum makes sound, but not when the drum is not making sound. We analyze our data as a class to identify another cause and effect relationship. Sound can cause other objects to vibrate. Finally, we engage in another read aloud that helps us connect our classroom observations with others' experiences and our own. At this point in the unit, we're ready to take stock and see if we can develop a fuller explanation of the unit phenomenon. It's time for a putting pieces together lesson. We're going to connect the ideas we figured out from the last several lessons and see if we've answered our lesson set question. In this case, about how objects make and send sound signals. In this putting pieces together lesson, we revisit our model from lesson 1 to notice that our ideas about how the clock tower makes and sends a sound signal have changed and grown. We review evidence we have gathered using a chart that we have been adding to since lesson 2 called our Growing Ideas chart. And then we build a gotta have it checklist that will help us explain our understandings. We develop individual models, which provides a summative assessment opportunity and supports our own sense-making. We use these models during a consensus discussion to make a class model. Then we connect our understandings to other examples of sound signals by adding examples from our out-of-school community connections to that Our Examples chart from Lesson 1. Through this work, we figure out that our model explaining how the clock tower makes and sends sound signals can explain other examples too. We end Lesson 5 considering these many different examples of objects that make sound signals. We ask questions about what these different sound signals might mean and why people might use these objects and signals when there are so many other ways we can communicate every day. These questions lead us into the unit's second lesson set. So Unit 1.2 is designed as 2 lesson sets, making Lesson 6 another anchoring phenomenon lesson. We call this a re-anchor. Like in Lesson 1 and other anchoring phenomenon lessons, its purpose is to introduce an interesting phenomenon or problem that motivates us to ask and answer questions. In this unit, the re-anchor lesson allows us to define our own engineering problem, which drives our learning and engineering through Lesson 10. So in Lesson 6, our re-anchor lesson, we return to our examples chart, which we just used in Lesson 5, to consider the messages that each sound signal is being used to communicate. We begin to use the word device to describe objects that are made for specific purposes, and we work in pairs to organize different sound signal devices based on the type of message they sent. We identify some different categories, including time messages, pay attention messages, and good news messages, and discuss them in the context of our own classroom. We notice that we use sound signal devices for many purposes in our classroom, but we don't have a sound signal device that we use to send good news messages. We think communicating good news is important, and it could make our classroom even better. So we read a newspaper article to connect with other students and engineers and find out more about how they made things better in their schools and communities. This helps us identify the engineering problem we want to solve. We want to find a way to communicate good news across our classroom. We decide we want to make a sound signal device to solve our problem, and we co-develop the unit's second lesson set question. How can we make sound signal devices to communicate a good news message across our classroom? We end our lesson by starting an ideas and wonders chart, sharing our ideas and asking questions related to making sound signal devices. In the second lesson set's investigation lessons, students continue to engage in science and engineering practices with a strong emphasis on engineering practices in this particular unit's storyline. Students continue to collaborate around plans of action, and the teacher continues to provide students with the space they need to grapple with and engage in engineering in ways that use their science ideas from the first lesson set and enrich that sense-making. Again, the engineering context is how can we make sound signal devices to communicate a good news message across our classroom? So in Lesson 7's investigation lesson, we use our experiences from our investigations in Lesson Set 1 to figure out that we need to make a plan to help us make our sound signal devices. We use a book to find out how an engineering team, including the engineer Matthias Dermond, makes plans to solve their engineering problem. We learn they do this by gathering information and making designs. So then we gather information by revisiting instruments from Lesson Set 1, like the triangle, box guitar, and shaker, to notice the specific parts that make sound. In this way, we're gathering new information about familiar objects. We're noticing how the instrument's parts, or structures, function for making sound. Next, we decide to make a device gotta have it checklist, like the gotta have it checklist we used in Lesson 5 when we developed our models, to help us determine what we need to include in our devices to solve our engineering problem. we decide our sound signal devices need to make sounds, so they need a part that vibrates. And they need to send a sound signal across the classroom so everyone can hear it. Then, individually, we draw initial designs for our sound signal devices, and after this, we collaborate with partners to combine ideas into one drawn design. Because collaborating around shared designs is an important part of engineering endeavors and can help us making our own drawn designs better. We leave this lesson with questions reflecting how eager we are to begin building our designs. Now, in this Lesson 8 investigation, we remind ourselves of the engineering problem we are trying to solve. We need a way to communicate a good news message across the classroom. And then we continue to use our informational text to find out how engineers like Matthias Dermond use materials and drawn designs to build devices. We select our materials using a materials menu, and we work with our engineering partners to use our drawn designs to build our sound signal devices. We continue to refer to our Device Gotta Have It checklist to guide our engineering. This helps us ensure that we use materials that vibrate to make sound. And then we reflect on our engineering and take a gallery tour to notice and consider our peers' examples of sound signal devices. We move into Lesson 9, motivated to find out how well our sound signal devices work. We use our engineering book to find out how Matthias Dermond tested his solution. And then we make connections to the work we did in Lesson Set 1 to plan and carry out investigations. We connect those experiences to our Device Gotta Have It checklist to guide us in making a plan for testing. We use the Testing Our Sound Signal Device handout on this slide to help us record data from our tests. We figure out that making and recording observations provides data we can analyze to figure out how well our devices work. Teachers have an opportunity during this testing to engage in discussions with students about how their devices are working, using questions like, does your device send a sound signal across the classroom? What is your evidence? Then, in small groups, students discuss with each other and provide feedback about how well each sound signal device worked, using the class's Device Gotta Have It checklist and the observations from testing. Giving and receiving peer feedback helps us recognize that designs can always be improved. Like the first Putting Pieces Together lesson in 1.2, students connect what they have figured out from this series of lessons in the second lesson set as they move into Lesson 10. In this case, students are making connections across their engineering to consider multiple solutions to the unit's engineering problem, and they work as a class to develop a better understanding of how multiple designs can solve their engineering problem, specifically how we need a way to send a good news message across our classroom. In the final Putting Pieces Together lesson, we want to share how our sound signal devices work with our classmates. We return to our book to find out how engineers share their designs. Then we use our Device Gotta Have It checklists to plan to communicate about our devices. We use the checklist to help us decide that we should show or share how our device makes sound and has a part or parts that vibrate. And we should show and share how our device sends a sound signal across the classroom so everyone can hear it. Then we present our sound signal devices, allowing us to explain to our classmates how our devices work to solve our engineering problem, and providing another summative assessment opportunity. We use a gallery tour to observe everyone's devices and then reflect on our work as engineers. We compare our designed devices, recognizing how many different designs can work to solve the same engineering problem. And then we use them to celebrate our good news. We have completed our unit. Now that we've overviewed Unit 1.2 storyline, we'd like to highlight a few key features that are part of the unit. This is the first unit in grade 1 that includes engineering performance expectations. And we want to highlight some of the supports for engineering that are included. Throughout lesson set 2, students use a Meet the Engineer book to figure out how engineers design solutions to engineering problems. These ideas help support students' work, planning, building, and testing their sound signal devices. Various student and teacher-facing supports are provided through slides, callouts in the teacher guides, and through our classroom agreements, all geared towards supporting students in working together in engineering partnerships, listening and responding to each other's ideas, providing feedback and responding to feedback from peers, and around organizing materials and instructional time in manageable ways. We also want to highlight how planning and carrying out investigations is well addressed and scaffolded throughout the unit. Like in Unit 1.1, it is an intentionally developed science and engineering practice. In 1.2, intentional scaffolds include a Scientists Do book around making and using observations that is first used in Lesson 2 and is available throughout the unit for referencing. Also, in Lessons 2, 3, and 4, students use the same template for their investigation plan charts, scaffolding their work planning investigations. This template supports students in considering how they will use materials, like instruments, as well as how they will make and record observations using their senses. Then in Lesson 9, students return to that same template to make a parallel plan for testing their sound signal devices, reinforcing how science and engineering practices coordinate and support each other. Also, we strive to design units that are relevant and interesting to students in classrooms across the country and in different contexts. One of the supports we provide in this unit is a reference, providing guidance to teachers who may want to localize the anchoring phenomenon in Lesson 1 by replacing it with a local clock tower or a similar sound signal device, or by using a different but locally relevant device. Additionally, students are encouraged across lessons to make connections to their own outside of school experiences with sound making devices, such as instruments, as well as sound signal devices. These connections are explicitly built on in Lessons 5 and 6 as students transition from figuring out science ideas, such as how vibrations cause sound, to using those same ideas in Lesson Set 2 to solve their classroom's engineering problem. Next, we'll briefly overview the standards for Unit 1.2, Waves, Sound. The unit builds toward 2 physical science, or PS, performance expectations, 1-PS4-1, which is plan and conduct investigations to provide evidence that vibrating materials can make sound and that sound can make materials vibrate, and 1-PS4-4. Use tools and materials to design and build a device that uses light or sound to solve the problem of communicating over a distance. Additionally, the unit builds toward all 3 of the K-2 Engineering, Technology, and Application of Science, or ETS, performance expectations. These include K-2-ETS 1-1, ask questions, make observations, and gather information about a situation people want to change to define a simple problem that can be solved through the development of a new or improved object or tool. K-2-ETS 1-2, develop a simple sketch, drawing, or physical model to illustrate how the shape of an object helps it function as needed to solve a given problem. And K-2-ETS 1-3, analyze data from tests of 2 objects designed to solve the same problem to compare the strengths and weaknesses of how each performs. Unit 1.2 intentionally develops 3 science and engineering practices, meaning that these practices are used by students repeatedly and with increased independence throughout the unit. These include developing and using models, planning and carrying out investigations, and constructing explanations and designing solutions, specifically the designing solutions practices, occur during engineering in lesson set 2. Unit 1.2 intentionally develops the cross-cutting concepts of cause and effect, specifically around how vibrating objects cause sound and sound can cause objects to vibrate, and structure and function, specifically around how structures or parts of instruments and sound signal devices function to make sound or for other purposes.
Right, Christy, I have a question.
Yes.
Can you talk a little bit about some of the supports you all implemented in this unit for students that may have hearing challenges?
Oh, yes. Thank you so much for asking that question. That's a really important one. We have a lot of supports built into the unit, primarily through call outs for teachers that are in the sidebar of the teacher guide, helping teachers provide the kind of support that a student with hearing impairments or differences might need. These include connecting students to tactile observations from the very beginning of the unit, providing opportunities to engage with sound making materials like instruments in spaces that are quieter, among many other things. This is one of the places where we leaned on some of our integration team specialists for their background and support. And there are notices to teachers about using resources in your own buildings and districts, instructional specialists and special education support staff who may be able to give other specific guidance.
Thank you so much, Christy.
Thank
All right, here we go to the next slide.
Yes.
All right, everyone. So if you're interested in attending any of our upcoming webinars, you can find them on our website. And also you can find archived webinars under our on-demand page and in each individual unit page. And we thank you all for being here today.